Ladies and gentlemen, it's time to get wise. It's time for TechWise, brand new show. My name is Eric Cavanaugh. I'm going to be your moderator for our inaugural episode of TechWise. That's exactly right. This is a partnership with Techopedia and the Bloor Group, of course, of Inside Analysis fame. My name is Eric Cavanaugh. I will be moderating this really interesting and involved event, folks. We're going to be digging deep into the weeds to understand what is going on with this big thing called Hadoop. What is the elephant in the room? It's called Hadoop. We're going to try to figure out what it means and what's going on with it. First of all, big thank you to our sponsors, GridGain, Acan, Zettaset, and Data Torrent. We'll get a brief few words from each of them near the end of this event. We'll also have a Q&A, so don't be shy. Send your questions in at any time. We'll dig into the details and throw the hard questions at our experts. And speaking of the experts, hey, there they are. So we're going to be hearing from our very own Dr. Robin Bloor. And folks, I'm very excited to have the legendary Ray Wang, Principal Analyst and Founder of Constellation Research. He's online today to give us his thoughts. And he's like Robin in that he's incredibly diverse and really focuses on a lot of different areas and has the ability to synthesize them and to really understand what is going on out there in this whole field of information technology and data management. So there's that little cute elephant. He's at the beginning of the road, as you can see. It's just beginning now. It's just kind of starting. This whole Hadoop thing, of course, back in 2006 or 2007, I suppose, is when it was released to the open source community. But there have been a lot of things going on, folks. There have been huge developments. In fact, I want to bring up this story, so I'm going to do a quick desktop share. At least I think I am. Yeah, let's do a quick desktop share and show you this just crazy, crazy story, folks. So Intel invests $740 million to buy 18% of Cloudera. I saw that, I'm like, holy Christmas. I started doing the math, and it's like, well, that's an evaluation of $4.1 billion. Well, let's think about this for a second. I mean, if WhatsApp is worth a couple billion, I suppose Cloudera might as well be worth $4.1 billion, right? I mean, why not? Some of these numbers are just out the window these days, folks. I mean, typically in terms of investment, you have EBITDA and all these other various mechanisms, multiples of revenue and so forth. Well, it would be one heck of a multiple of revenue to get to $4.1 billion for Cloudera, which is an awesome company. Don't get me wrong. Some very, very smart people over there, including the guy who started the whole Hadoop craze, Doug Cutting. He's over there. A lot of very intelligent people. They're doing a lot of really, really cool things. But, you know, the bottom line is that $4.1 billion, that's a lot of money. So here is kind of a Captain Obvious moment that's going through my head right now, which is a chip, Intel, their chip designers. Are we going to see some Hadoop optimized chip? I have to think so, folks. That's just my guess. That's just a rumor coming from me, if you will, but it kind of makes sense. And what does this all mean? So here's my theory. What is happening, a lot of this stuff is not new. Massive parallel processing is not terribly new. Parallel processing sure is not new. It's been in the world of supercomputing for a while. A lot of these things that are happening are not new, but there is this sort of general awareness that there's a new way to attack some of these problems. And what I see happening, if you look at some of the big vendors, your Cloudera, your Hortonworks, some of these other guys, what they're doing really, if you boil it down to the most granular, distilled level, is application development. That's what they're doing. They're designing new applications. Some of them involve business analytics. Some of them just involve supercharging systems. One of our vendors is going to talk about that. They do that kind of stuff all day on the show today. But is it terribly new? Again, the answer is not really. But there is big stuff happening, and personally, I think what's going on with Intel, making this huge investment, it's a market-making move. They look at the world today and see that it's kind of a monopoly world today. There's Facebook. I mean, they're beating just the snot out of poor MySpace. LinkedIn is beating the snot out of poor who's who. So you look around, and it's one service that is dominating all of these different spaces in our world today, and I think the idea is Intel's going to throw all their chips on Cloudera and try to elevate it to the top of the stack. That's just my theory. So, folks, like I said, we are going to have a long Q&A session, so don't be shy. Send your questions in at any time. You can do so using that Q&A component of your webcast console. And with that, I'm going to get to our content because we've got a lot of stuff to get through. So, Robin, Bloor, let me hand the keys over to you, and the floor is yours.
Okay, Eric, thanks for that. Let's bring on the dancing elephants. It's a curious thing, actually, that elephants are the only land mammals that can't actually jump. But all of these elephants in this particular graphic have got at least 1 foot on the ground. So I suppose it is feasible. But to a certain extent, these are obviously Hadoop elephants, so are very, very capable. The question really, I think, has to be discussed, and it has to be discussed in all honesty, right? It has to be discussed at a technical level before you go anywhere else, which is to really start talking about what Hadoop actually is. You know, and one of the things that it absolutely is, fundamentally at base, is it's a key value store. We used to have key value stores. We used to have them on IBM mainframe. You had them on the mini computers. DECVAX had RMS files. There were ISAM capabilities that were on pretty much every mini computer you could get your hands on. But sometime around the late 80s, Unix came in, and Unix didn't actually have any key value store on it. And when Unix developed, and they developed very swiftly, what happened really was that the database vendors, particularly Oracle, went steaming in there, and they sold you databases to look after any data that you cared to manage on Unix. Windows and Linux turned out to be the same. So the industry went for the best part of 20 years without a key value store, general purpose key value store. Well, it's back now. And not only is it back, it's scalable. And that, I think, is really, it's the foundation of what Hadoop really is. And to a certain degree, it determines where it's going to go. But what do we like about key value stores? Those of you who are as old as I am and actually remember working with key value stores realize that you could pretty much use them to informally set up a database, but only informally. You know, the metadata for a key value store is in the program code, but you could actually make that an external file, and you could, if you wanted to, start treating a key value store a little like a database. But of course, it didn't have all that recovery capability that a database has, and it didn't have an awful lot of things that databases have now got. But it was a really useful feature for developers, and that's one of the reasons I think that Hadoop has proved so popular. Simply because it has been coders, programmers, developers that have picked it up. And they've realized that not only is it key value to store, but it's a scale-out key value store. And it scales out pretty much indefinitely. It certainly scales out into thousands of servers. So that's the really big thing about Hadoop, is that's what it is. It also has on top of it MapReduce, which is a parallelization algorithm. But actually, that's, in my opinion, not that important. So, you know, Hadoop the Chameleon. It's not just a file system. I've seen various kind of claims made for Hadoop. It's a SQL database. It's a NoSQL database. It's a column store. It's an analytical toolbox. It's an ELT environment. It's a data cleansing tool. It's a streaming platform. It's a data warehouse. It's an archive store. It's a cure for cancer, and so on. Most of these things are really not true for vanilla Hadoop. Hadoop is probably a prototyping, and it's certainly a prototyping environment for a SQL database, but it doesn't really have, if you put, you know, HBase with hcatalog over Hadoop, you've got something that looks like a database, but it's not really what anyone would call a database in terms of capability. You know, and a lot of these capabilities, you can certainly get them on Hadoop. There are certainly a lot of them, in actual fact, you can get as open source as Hadoop. But Hadoop itself is not what I would call operationally hardened, and therefore the deal about Hadoop, really above and beyond anything else, is that you kind of need to have third-party products to enhance it. So talking about, because I want to draw a few lines in the sand, talking about Hadoop overreach. First of all, real-time query capability. Well, you know, real-time is kind of business time, really. Almost always performance critical. Otherwise, I mean, why would you engineer for real-time? Hadoop doesn't really do this. It does something that's near real-time, but it doesn't really do real-time stuff. It does streaming, but it doesn't do streaming in a way that I would call really, mission-critical type application streaming platforms can do. There's a difference between a database and a queryable store. SQL 92 over Hadoop gives you a queryable data store. That's kind of like a database, but it's not the same as a database. Hadoop in its native form, in my opinion, doesn't really qualify as a database at all because it's short quite a few things a database should have. Hadoop does OLAP, but it doesn't do it particularly well. Again, the capability is there, but we're a ways away from actually having a fast capability in all of these areas. The other thing to understand about Hadoop, it's kind of come a long way since it was developed. It was developed in the early days. It was developed when we had servers that actually only had one processor per server. We never had multi-core processors. And it was built to run over grids, large grids of servers. The goal, one of the design goals behind Hadoop was to never lose the work. And that was really about disk failure, because if you've got hundreds of servers, then the likelihood is, if you've got disks on those servers, the likelihood is that you'll get, I don't know, an uptime availability of something like 99.8. That means that you'll get on average a failure of one of those servers once every 300 or 350 days, one day in a year. So if you had hundreds of these, the likelihood would be on any day of the year that you'd get a server failure. And Hadoop was built specifically to address that problem, so that in the event that anything failed, it's taking snapshots of everything that goes on every particular server, and it can recover the batch job that's running. And then that was all that actually ever ran on Hadoop, was batch jobs. And that's a really useful capability, it has to be said. Some of the batch jobs that were being run, particularly at Yahoo, where I think Hadoop was kind of born, would be running for 2 or 3 days, and if it failed after a day, you really didn't want to lose the work that had been done, So that was the design point behind the availability on Hadoop. You wouldn't call it high availability, but you could call it high availability for serial batch jobs. That's probably the way to look at it. High availability is always configured according to workload characteristics. At the moment, Hadoop can only be configured for really serial batch jobs as regards that kind of recovery. Enterprise high availability is probably best thought in terms of transactional OLP, at the least. If it's not, if you're not looking at it as a kind of real-time thing. Hadoop doesn't do that yet, and it's probably a long ways away from doing that. But here's the beautiful thing about Hadoop. That graphic on the right-hand side there has got a list of vendors around the edge, and all of the lines on it indicate connections between those vendors and other products in the Hadoop ecosystem. And if you look at that, that is an incredibly impressive ecosystem. It's quite remarkable. And we talk to a lot of vendors in terms of their capabilities. And amongst the vendors I've talked to, there are some really extraordinary capabilities of using Hadoop in an in-memory way, of using Hadoop as a compressed archive, of using Hadoop as an ETL environment, and so on and so forth. But really, if you add the product to Hadoop itself, it works extremely well in a particular space. So while I'm being critical of native Hadoop, I'm not critical of Hadoop when you actually add some power to it. In my opinion, Hadoop's popularity is going to guarantee its future. And by that I mean, even if every line of code that's written so far on Hadoop disappears, I don't believe that the HDFS API will disappear. In other words, I think the file system API is here to stay, and possibly Yarn, the scheduler, that sits over it. And when you actually look at that, that's a very important capability, and I'll kind of wax on about that in a minute. But the other thing that is, let's say, exciting people about Hadoop is the whole of the open source picture. So it's worth going through what the open source picture is in terms of what I regard as real capability. Well, Hadoop and all its components can certainly do what we call data lakes, or what I prefer to call as a data reservoir. Certainly a very good staging area to drop data into the organization or to collect data in the organization. Extremely good for sandboxes and for wrangling data. It's very good as a prototyping development platform, which you might implement at the end of the day, but as a development environment, pretty much everything you want is there. As an archive store, it's pretty much got everything it needs, and of course it's not expensive. And I don't think we should divorce either of these two things from Hadoop, even though they're not formally, if you like, components of Hadoop. The R language has brought a vast amount of analytics into the open source world, and a lot of that analytics is now being run on Hadoop because that gives you a convenient environment in which you can actually take a lot of external data and just start playing. That's an analytical sandbox. And then we've got the NIME and Mahout open source capabilities, both of which are machine learning. Both of those are extremely powerful in the sense that they implement powerful analytical algorithms. And if you put these things together, you've got the kernel of some very, very important capability, which is, in one way or another, very likely to, whether it develops on its own or whether vendors come in to fill in the missing pieces, is very likely to continue for a long time. And certainly I think the machine learning is already having a very big impact on the world. The evolution of Hadoop, Yarn changed everything. What had happened was MapReduce was pretty much welded to the file system HDFS. Well, when Yarn was introduced, it created a scheduling capability. It's in its first release. You don't expect extremely sophisticated scheduling from first release, but it did mean that it was now no longer necessarily a batch environment. It was an environment in which multiple jobs could be scheduled. And as soon as that happened, there's a whole series of vendors who had kept away from Hadoop, but just came in and connected to it, because then they could just look at it as a scheduling environment over a file system, and they could add their stuff to it. There are even database vendors that have implemented their databases on HDFS because they just take the engine and just put it over HDFS. With cascading and with Yarn, it becomes a very interesting environment because you can create complex workflows over HDFS, and this really means that you can start thinking of it as a platform that can be running multiple jobs concurrently and is pushing itself towards the point of doing mission critical stuff. And if you're going to do that, you're going to probably need to buy some third-party components like security and so on and so forth, which Hadoop doesn't actually have, in order to kind of fill in the gaps. But you're getting to the point where even with native open source, you can do some interesting things. In terms of where I think Hadoop is actually going to go, I personally believe that HDFS is going to become a default scale-out file system, and therefore it's going to become the OS, the operating system for the grid for data flow. I think it's got a huge future in that, and I don't think it will be stopped in that. And I think in actual fact the ecosystem just helps, because pretty much everybody, all the vendors in the space are actually integrating with Hadoop in one way or another, and they're just enabling it. In terms of another point worth making in terms of Hadoop overage, it's not a very good platform for parallelization. It's, if you actually look at what it's doing, what it's actually doing is it's taking a snapshot regularly on every server as it's executing its MapReduce jobs. If you were going to design for really fast parallelization, you wouldn't be doing anything like that. In actual fact, you probably wouldn't be using MapReduce on its own. MapReduce is only what I would say half capable of parallelism. There's two approaches to parallelism. One is by pipelining processes, and the other is by dividing data. MapReduce only does the data division of data. So there are a lot of jobs where MapReduce would not actually be the fastest way to do it, but it will give you parallelism. I mean, there's no taking away from that. And when you've got a lot of data, that kind of parallelism is usually useful. Yarn, as I've already said, is a very young scheduling capability. Hadoop is, I mean, I'm kind of drawing a line in the sand here. Hadoop is not a data warehouse. It's so far from being a data warehouse that it's almost an absurd suggestion to say that it is. And this diagram, you know, what I'm showing along the top is a kind of data flow going from a Hadoop data reservoir into a scale-out, gargantuan scale-out databases, which is what we'll actually do an enterprise data warehouse. And, you know, I'm showing legacy databases feeding data into the data warehouse, and offload activity creating offload databases from a data warehouse. But that is actually a picture that I'm starting to see emerge. I would say this is like the first generation of what happens to the data warehouse with Hadoop. But if you look at the data warehouse itself, you realize that underneath the data warehouse, you've got an optimizer, you've got distributed query workloads over very many processors, sitting over very many memory, sitting over perhaps very many large number of disks. That's what happens in a data warehouse. That's the kind of architecture that's built for a data warehouse, and it takes, you know, it takes a good long time to build something like that. And Hadoop doesn't have any of that at all. So Hadoop's not a data warehouse, and it isn't going to become one, in my opinion, anytime soon. But it does have this role as a data reservoir, and it kind of looks interesting. If you just look at the world as a series of events flowing into the organization, that's what I'm showing on the left-hand side of this diagram. Have it go through a filtering and routing capability, and the stuff that needs to go for streaming gets siphoned off of the streaming apps, and everything else goes straight into the data reservoir, where it's prepared and cleansed and then passed via ETL to either a single data warehouse or a logical data warehouse consisting of multiple engines. This is a natural, in my opinion, natural development line for Hadoop. So in terms of the EDW, you know, one of the things that is worth kind of pointing out is that the data warehouse itself has actually moved. It's not what it was. Certainly nowadays you expect there to be a hierarchical capability for hierarchical data, or what some people call documents in the data warehouse. That's JSON. Possibly network queries, that's graph databases, possibly analytics. So what we're moving towards is an EDW that is actually got a more complex workload than the ones that we're used to. So that's kind of interesting, because in a way it means that the data warehouse is getting even more sophisticated, and because of that, it's going to be even longer time before Hadoop gets anywhere close to it. The meaning of data warehouse is extending, but it still includes optimization. You have to have an optimization capability, not just over queries now, but over all of these activities. And that's it, really. That's all I wanted to say about Hadoop. I think I can hand on to Ray, who hasn't got any slides, but he's always good at talking.
Actually, I'll take it. I'll take the slides, and there's our friend Ray Wang. So, Ray, what are your thoughts on all this?
No, I think that was probably one of the most succinct and great histories of key value stores and where Hadoop has gone in relationship to enterprise data warehouse. So I always learn a lot listening to Robin. I actually do have one slide. I can pop up one slide here.
Let me go ahead and I'll give you
control. I will pop
up. Let me give you control. There you go. Just go ahead and click on the quick start and go to share your desktop.
Got it. Very cool.
There you go.
So let me do that. I'll actually share a...
There you go.
And you can see the app itself. Let's see how it goes. So all this talk about Hadoop, I know we go deep into the conversation about the technologies that are there and where Hadoop is heading. And a lot of times I just like to take it back up to really have the business discussion. And a lot of the stuff that's happening on the technology side is really this piece where we've been talking about data warehouses, information management, data quality, mastering that data. And so we tend to see that. So if you look at this graph here on the very bottom, it's very interesting the types of individuals we bump into that talk about Hadoop. We have the technologists and the data scientists that are geeking out, having lots of excitement, and it's typically about data sources, right? How do we master the data sources? How do we get this into the right levels of quality? What do we do about the governance? What can we do to match different types of sources? How do we keep lineage and all that kind of discussion? And how do we get more SQL out of our Hadoop? And so that part is happening at this level. Then at the information and orchestration side, this is where it gets interesting, where we're starting to tie the outputs of this insight that we're getting, where we're pulling it from back to business processes. How do we tie it back to any kind of metadata models? Where are we connecting the dots between objects? And so the new verbs and the new verbs and discussions about how we use that data, moving from what we traditionally are in a world of CRUD, create, read, update, delete, to a world that is discussing about how do we engage or share or collaborate or like or pull something. That's where we're starting to see a lot of the excitement and innovation, especially about how to pull this information and bring it to value. Now, that is the technology-driven discussion below the red line. Above that red line, we're getting the very questions that we always wanted to ask. And one of them that we always bring up is like, you know, for example, maybe the question in retail for you is like, why are, you know, red sweaters selling better in Alabama than blue sweaters in Michigan, right? And you could think about it and you're saying, that's kind of interesting. So we see that pattern, we ask that question, and then we wonder, hey, what are we doing? Is this about, well, maybe it's about state schools, right? Michigan versus Alabama. Okay, I get this. I see where we're going. And so we're starting to get the business side of the house, people in finance, people who've got traditional BI capabilities, people in marketing, even people in HR saying, what are my patterns? How do we get to those patterns? And so we see another wave of innovation on the Hadoop side, really about how do we surface up these insights faster? How do we make these kind of connections? And it goes all the way to the folks who are doing like ad tech. They're trying to connect, you know, basically they're trying to connect ads and relevant content from anything from real-time bidding networks to contextual ads and ad placements, and doing that on the fly. And so it's interesting to watch this, right? You see the progression of Hadoop from, hey, here's the technology solution, here's what we need to do to get this information out to people, and then as it crosses over to the line of business portion, this is where it gets interesting. It's the insight. Where's the performance? Where's the deduction? How are we predicting things? How do we take inference? And then bring that to that last level where we actually see another set of Hadoop innovations that are happening around decision systems and actions, right? What's the next best action? So you know blue sweaters are selling better in Michigan. You're sitting on a ton of blue sweaters in Alabama. The obvious thing is, yeah, well, let's get these shipped out there, right? How do we do it? What's the next step? How do we tie that back in to maybe it's a next best action, maybe it's a suggestion, maybe it's something that helps you prevent an issue, maybe it's no action either, which is an action in itself. And so we start seeing these kind of patterns emerge. And the beauty of this, back to what you were saying about key value stores, Robin, is that it's happening so fast. It's happening in a way that, you know, we haven't been thinking about it this way. Probably, I'd say in the last 5 years, we picked up, right? We started thinking in terms of how we can leverage key value stores again, but it hasn't been, it's just been the last 5 years. People are looking at this very differently. And it's like technology cycles are repeating itself in 40-year patterns. So this is kind of our funny thing. We're looking at, you know, cloud, and I'm just like mainframe, time sharing. We're looking at Hadoop, and I'm like key value store. Wait, maybe it's a data mart, less than a data warehouse. And so we start seeing these patterns again. And so what I'm trying to do right now is think about what were people doing 40 years ago? What approaches and techniques and methodologies were being applied that were limited by the technologies people had. And that's kind of driving this thought process. So as we go through the larger picture of, you know, Hadoop as a tool, when we go back and think about the business implications, this is kind of the path that we usually take people through so you can see what pieces, what parts are in this data to decisions pathway. So just something I wanted to share. It's kind of the thinking that we've been using internally and hopefully adds to the discussion. So I'll turn it over back to you, Eric.
That's fantastic. And if you can, stick around for some Q&A, but I like that you took it back up to the business level because at the end of the day, it's all about the business. It's all about getting things done and making sure that you're spending money wisely. And that is one of the questions I saw already. So speakers may want to think about, what is the TCO of going the Hadoop route? There is some sweet spot in between, for example, using off-the-shelf tools to do things in some traditional way and using these new sets of tools because, again, think about it. A lot of this stuff is not new. It's just sort of it's coalescing in a new way is, I guess, the best way to put it. So let's go ahead and introduce our friend Nikita Ivanov. He is the founder and CTO of GridGain. And Nikita, I'm going to go ahead and hand the keys to you. And I believe you're out there. Can you hear me, Nikita?
Yes, I'm here.
Excellent. So the floor is yours. Click on that slide, use the down arrow, and take it away. 5 minutes.
And which arrow do I click?
Just click anywhere on that slide, and then use the down arrow on your keyboard to move. So just click on the slide itself and use the down arrow.
Got it. Got it. All right. So just a few quick slides about GridGain and what we're doing in context of this conversation. We're GridGain basically producing in-memory computing software, and part of the platform that we developed is in-memory Hadoop accelerator. And in terms of Hadoop, we tend to think about ourselves as the Hadoop performance specialists. What we do essentially, on top of our core in-memory computing platform that consists of technologies like data grid and memory streaming and computational grids, we developed a plug-and-play Hadoop accelerator. That is very simple. Would be nice if we can develop some kind of plug-and-play solution that can be installed right in the Hadoop installation and give you, the developer of MapReduce task, an immediate boost without any need to write any new software or change your code or basically have an only minimal configuration change in the Hadoop cluster. And that's what we developed. So fundamentally, the in-memory Hadoop accelerator is based on optimizing two components in the Hadoop ecosystem. If you think about Hadoop, it's predominantly based, as Rob mentioned, it's based on HDFS, which is the file system, and the MapReduce, which is the framework to run the computations in parallel on top of the file system. In order to optimize the Hadoop, we optimized both of these subsystems. We developed in-memory file system that is completely compatible, 100% compatible plug-and-play with HDFS. You can run instead of HDFS, you can run on top of HDFS. And we also developed in-memory MapReduce that is plug-and-play compatible with Hadoop MapReduce, but does a lot of optimizations on how the workflow of MapReduce and how the scheduling of work MapReduce works. So if you look, for example, on this slide where we show the stack of typical Hadoop application, on the left side you have your typical operating system, the JVM, and on top of this stack you have your applications, and everything in the middle you have the Hadoop. And Hadoop is again based on HDFS and MapReduce. So there's those red pieces on this diagram. That's what we're kind of embedding into the Hadoop stack. Again, it's a plug and play. You don't have to change any code. It just works the same way. And on the next slide, we're showing you essentially how we optimize the MapReduce workflow. So that's probably the most interesting part because it gives you the most advantage when you're running the MapReduce jobs. So the typical MapReduce scenario when you submitting a job, and on the left side of this diagram is user application. So typically you are submitting the job, and the job goes to the job tracker. It interacts with the Hadoop name node, and the name node is essentially the piece of software that manages the interaction with HDFS and kind of keeps the directory of files. And then the job tracker interacts with the task tracker on each individual node, and the task tracker interacts with a Hadoop data node to get data from. So that's basically a very kind of high-level overview of how your job, your MapReduce job, gets executed. So as you can see, what we do with our in-memory Hadoop MapReduce, we allow you to completely bypass all this complex scheduling that takes a lot of time off your execution and go directly from a client to a GridGain data node. And GridGain data node keeps all the data in memory for a blazingly fast execution. So all in all, basically, we allow you to get anywhere from 5x up all the way to 100x performance increase on certain types of payloads, especially for short-lived payloads when you literally measure on every second, we can give you a dramatic boost in performance with literally no code change.
Wow.
All right, that's all for me.
Hey, that's good
stuff. Obviously, if you guys have any questions, I'll
no
more than
doubt.
happy to answer.
Yeah, stick around for the Q&A, no doubt about it. Let me hand it off to John Santaferraro. And John, just click on that slide, use the down arrow to move on.
All right, thanks a lot, Eric. I want to talk the perspective, my perspective and Acan's perspective really is that Hadoop is really about creating value, and so this is an example from digital media. A lot of the data that is pumping into Hadoop right now has to do with digital media, digital marketing, customer, and so there's great opportunity. $226 billion of retail purchases will be made online next year. Big data and Hadoop is about capturing new data to give you insight to get your share of that. How do you drive 14% higher marketing return and profits based on figuring out the right media mix and the right channels and the right digital marketing plan? How do you improve overall return on marketing investment? And by the way, in 2017, what we ought to be thinking about when we look at Hadoop is the fact that CMO, Chief Marketing Officer, spending in 2017 will outpace that of IT spending. And so it really is about driving value. And so our view is that there's all kinds of noise being made on the left-hand side of this diagram, the data pouring in to Hadoop. Ultimately, our customers are wanting to create customer delight, competitive advantage, world-class risk management, disruptive new business models, and to do all of that to deliver transformational value. So they're looking to capture all of this data in Hadoop and be able to do best-in-class kinds of things like discovery on that data without any limitations, low latency at any scale of the data that lives in. They're moving from reactive to predictive kinds of analytics and doing everything dynamically instead of looking at data just as static. What pours into Hadoop? How do you analyze it when it arrives? Where do you put it to get the high performance analytics? And ultimately moving everything down to a segment of one. And so what we've done at Acan is in the Acan Analytics platform, we have built an exoskeleton around Hadoop to give it all of these capabilities that you need. So you're able to connect to any data source, bringing it into Hadoop, delivering it as a data service wherever you need it. We have libraries of analytics and data blending and data enrichment kinds of operators that you literally drag and drop them so that you can build out these data and analytic workflows. And without ever doing any programming, we will push that workload via Yarn right down to the Hadoop node so you can do high-performance data science natively on Hadoop. So all of your data prep, all of your data science happening on Hadoop, highly parallelized, highly optimized, highly performant. And then when you need to, you move it to the right via a high-speed connection over to our high-performance analytic engine where you can do super low latency kinds of analytics. And all of that delivering out these real-time kinds of analytics to users, machine-to-machine kinds of communication, embedding those analytics in business processes, feeding big data apps or applications. And so this is an example of telco churn where the top of this chart, if you're just building telco churn, for example, where you've captured one kind of data and poured that into Hadoop, you're going to get I'd be able to identify about 5% of your potential churn audience. As you move down this chart and add additional kinds of data sources, you do more complex kinds of analytics in the center column there. It allows you to act against that churn in a way that allows you to identify. You move from 5% identification up to 70% identification. And so for telecommunications companies, for retail organizations, for any of the SaaS providers, anybody that has a customer base where there's a fear and a damage that is caused by churn, this kind of analytics running on top of that exoskeleton-enabled version of Hadoop is what drives real value. And so what you can see here is the kind of value. This is an example taken from off of the annual report of a telecommunications company that shows their actual total subscribers, 32 million. Their existing churn rate, which every telco reports, 1.14. 4.3 million subscribers lost every year, costing them $1.14 billion, as well as $2.1 billion in revenue. And so this is a very modest example of how you generate value out of your data that lives in Hadoop, where you can see the potential cost of reacquisition, where the potential here is to use Hadoop with the exoskeleton running analytics to basically help this telecommunications company save $160 million, as well as avoid $294 million in loss. So that's the kind of example that we think is driving Hadoop forward.
All right, fantastic. And Jim, let me go ahead and give the keys to you. So Jim Boat, if you would click on that slide and use the down arrow on your keyboard.
I've got it. Oh, great picture. Okay, thank you very much. Yeah, I'll tell you a little bit about Zettaset. We've been talking about Hadoop all afternoon here. And what's interesting about our company is that we basically spent our careers hardening new technology for the enterprise, being able to plug the gaps, if you will, in a new technology to allow it to be widely deployed within an enterprise operational environment. And so there's a couple things happening in the market right now. It's kind of like a big open pool party, right? But now the parents have come home. And basically, you know, we're trying to bring this thing back to some sense of reality in terms of how you build a real infrastructure piece here that can be scalable, repeatable, non-resource intensive, and secure, most importantly secure. And in the marketplace today, most people are still kicking the tires on Hadoop, and for the main reason is a couple of things. One is that within the open source itself, although it does some very useful things in terms of being able to blend data sources, deal with unstructured data and very useful data sources, it really lacks for a lot of the hardening and enterprise features around security, high availability, and repeatability that people need to deploy not just a 10 or 20 node cluster, but a 2,000, 20,000 node cluster, right, or multiple clusters. And what's been monetized in the last 2 years has been mainly pro services around setting up these eval clusters. So there's not a repeatable software process to actually actively deploy this into the marketplace. So what we built in our software is a couple of things. We're actually transparent to the distributions. At the end of the day, we don't care if it's CDH or HTTP, it's all open source, right? And if you look at the raw Apache components that build those distributions, there's really no reason why you have to lock yourself in any one distribution. And so we work across distributions. The other thing is that we fill in the gaps transparently in terms of some of the things that are missing within the code itself, the open source. So we've talked about HA. HA is great in terms of name node failover, but what happens if any of the active processes that you're putting on these clusters fail that could take it down or create a security hole, if you will? So when we build software components into our solution, they all fall under an HA umbrella where you're actively monitoring all the processes running on the cluster. If Kerberos goes down, you take the cluster down, right? So basically, name node failover is great, but unless you're actively monitoring all the processes running on the cluster, you don't have true HA. And so that's essentially what we've developed here at Zettaset, and in a way that we've actually got a patent that's been issued on this and granted last November around this HA approach, which is quite novel and different from the open source version and much more hardened for the enterprise. The second piece is being able to do real RBAC. People talk about RBAC. They talk about other open source projects. Why should you have to recreate all those entries and all those users and roles when they already exist in LDAP or on Active Directory? So we link those transparently, and then we fold all our processes not only under this RBAC umbrella, but also under the HA umbrella. Then you can start to layer into this infrastructure encryption at data at rest, data in motion, all the hardened security pieces that you need to really secure the information. And so what's really driving this is there are industries, which I have on the next slide, which talk to finance and healthcare that have hard compliances. You have to be able to protect this sensitive data, and you have to be able to do it in a very dynamic fashion because this data can be sitting anywhere across these parallel nodes and clusters, and it can be duplicated and so forth. So essentially, that's the big umbrella that we built. The last piece is that people need is they need to be able to put all the pieces together, right? And so having the analytics that John talked to and being able to get value out of the data and do that through an open interface, JDBC, ODBC, to tap this infrastructure, that's what we built in our software. So the three cases that I had in here, you guys are popping me along here, were really around finance, healthcare, and also cloud, where you're having to deal with multi-tenant environments and essentially have to separate people's sensitive data. So security and performance are key to this type of application, whether it's cloud or in a sensitive data environment. The last slide here really talks to this infrastructure we put together as a company is not just specific to Hadoop. It's something that we can equally apply to other NoSQL technologies, and that's where we're taking our company forward. And then we're also going to pull in other open source components, HBase and Pala and so forth, and secure those within that infrastructure in a way that you're not tied to any one distribution, so that you truly have an open, secure, and robust infrastructure for the enterprise. So that's what we're about, and that's what we're doing to basically accelerate adoption of Hadoop, so that people get away from 10 or 20 node clusters and actually have the confidence to deploy in much larger environments, gets more eyes on Hadoop, and speeds the market along. Thank you.
Nice. That's fantastic. Great. Stick around for the Q&A. And finally, last but not least, we've got Phu Huang, CEO of Data Torrent. Let me go ahead and hand the keys to you. Sorry, Phu Huang. And the keys are now yours. Click anywhere on that slide. Use the down arrow on your keyboard to move them along.
Thank you so much. So yes, I'm here to talk about Data Torrent, and I actually think it's the story of Data Torrent is a great example of what Robin and Ray have been talking about through this session, where they say that Hadoop is a great it was a great body of work, a great foundation, but it has a lot of holes. But the future is bright because the Hadoop ecosystem, where more players are coming in, are able to really add value on top of that foundation to really bring it from storage to insight to action. And really that's the story of Data Torrent. So what I'm going to discuss today is really about real-time big data stream processing. And what you see, as I'm interacting with customers, I've never met a single customer that says to me, hey, my goal is to take action hours or days after my business events arrive. In fact, they all say they want to take action immediately after the events occur. The problem with this delay is that that's what Hadoop is today with its MapReduce paradigm. And to understand why, it's worth revisiting the history of Hadoop. I was leading much of Yahoo engineering when we hired Doug Cutting, the creator of Hadoop, and assigned over 100 engineers to build out Hadoop to power our web search, advertising, and data science processing. But Hadoop was built really as a batch system to read and write and process these very large files. And so while it's great disruptive technology, because of its massive scalability and high availability and low cost, it has a hole in that it takes, there's a lot of latency to process these large files. Now, it's fair to say that Hadoop is now becoming the de facto operating system for distributed computing, and it's gaining wide adoption across many enterprises. They are still using that same process of collecting events into large files, running these batch Hadoop jobs to get their insights the next day. And what enterprise customers now want is that they want the exact same insights, but they want to be able to get these insights much earlier. And this will enable them to really act on these events as the event happens, not after many hours later after it's been batch processed. So
yeah, do you want to be moving your slides forward, just out of curiosity?
Yeah, it's coming now. Let me give that, illustrate that with an example, right? In this example, using Hadoop in batch mode, where you're constantly engaging with files, first an organization might accumulate all their events for the full day, 24 hours worth of data, and then they batch process it, which may take another 8 hours using MapReduce. And so now there's 32 hours of elapsed time before they get any insight. But with real-time stream processing, the events are coming in and are getting processed immediately. There is no accumulation time. And because we do all this stream processing all in memory, the in-memory processing is also sub-second. So all of a sudden, you're reducing the elapsed time from 30 hours plus to something that is very small. If you're reducing 30 hours to 10 hours, that's valuable. But when you can reduce it to a second, something profound happens. You can now act on your event while the event is still happening. And this gives enterprises the ability to understand what their product's doing, what their business is doing, what their users are doing in real time and react to it. So let's take a look at how this happens. Really, a combination of market forces and technology has enabled a solution like data torrent to come together. So from a market perspective, Hadoop is really becoming the de facto big data architecture, as we said, right? In an IDC study in 2013, they say that by the end of this year, 2/3 of enterprises would have deployed Hadoop. And for data torrent, whether that's Apache Hadoop or any of our certified partners like Cloudera, Hortonworks, or MapR, Hadoop is really clearly the choice for enterprise. Now, from a technology perspective, and I think Robin and Ray alluded to this, Hadoop 2.0 was created to really enable Hadoop to extend to much more general cases than the batch MapReduce paradigm. And my co-founder, Amal, who was at Yahoo leading the development of Hadoop 2.0, which is Yarn, really allows this layer of OS to have many more computation paradigms on top of it, and real-time streaming is what we chose. And by putting this layer of real-time streaming on top of Yarn, you can really think of data torrent as the real-time equivalent of MapReduce. And whatever you can do in batch with MapReduce, you can now do in streaming with data torrent. And we can process massive amount of data. We can slice and dice data in multiple dimensions. We leverage the distributed computing and use Yarn to give us resources. And we have the full ecosystem of the open source Hadoop to enable fast application development. Let me talk a little bit about the actual capabilities of data torrent. In 5 minutes, it's hard for me to kind of give it too much to you in detail, but let me just discuss some key differentiators. First of all, sub-second scalable ingestion, right? This refers to data torrent platform to be able to take events in real time from hundreds of data sources and begin to process them immediately. This is in direct contrast to the batch processing of MapReduce that is in Hadoop 1.0. And events can vary in size. They may be as simple as a line in a log file, or they may be much more complex, like CDR, call data records in the telecom industry. And data torrent is able to scale the ingestion dynamically up or down depending on the incoming load, and we can deal with tens of millions of incoming events per second. The other major capability, of course, is the processing itself, which we deem real-time ETL processing. So once the data is in motion, it's going to go into the ETL logic where you're doing extract, transform, and load, and so on. And the logic is really executed by combining a series of what we call operators connected together in a data flow graph. And we have open source over 400 operators today to allow you to build applications very quickly. And they cover everything from input connectors to all kinds of message buses to database drivers and connectors for you to load to all kinds of transformations on stream. And the combination of doing all this in memory and be able to scale across hundreds of nodes really drives the superior performance. Data torrent is really able to process billions of events per second with sub-second latency. The last piece to highlight is really the high availability architecture. The data torrent platform is fully fault tolerant. That means that the platform automatically buffers events and regularly checkpoints the state of the operators on disk to ensure that upon no failures, the applications can self-heal in seconds with no data loss and no human intervention. Simply put, data torrent processes billions of events analyzes data in seconds. It runs 24/7, and it never, ever goes down. So these capabilities really set Data Torrent apart from the market and really makes it the leading mission-critical real-time analytics platform for the enterprise. So with that, we invite you to come visit our website and check us out. Thanks.
Yeah, thank you so much. And I'll throw a question over to you, or really a comment, and let you kind of expound upon it. I really think you're on the ball here with this concept of turning over these operators and letting people use these operators almost like Legos to build big data applications. Can you kind of talk about what goes into the process of taking these operators and stitching them together? How do you actually do that?
That's a great question. So first of all, these operators are in your standard application Java logic. We supply 400 of them. They do all kinds of processing. And so to build your application, you really are just connecting operators together into a data flow graph. And in our customers, we find that they use a number of operators that we have in our library, as well as they take their own Java custom logic and make it an operator so that they can instantiate that into the graph.
Okay, good. And I think that's a good segue to bring in John Santaferraro from Acan, because you guys have a slightly similar approach, it seems to me, in opening up a layer, sort of management layer, to be able to play around with different operators. Can you talk about what you do with respect to what Fu was just talking about, John?
Yeah, exactly. We have a library of sorry, I'm getting a little feedback. We have a library of analytics operators, as well as transformational operators, operators for blending and enriching data. And it's very similar. You use a drag and drop interface to be able to stitch together these data flows or workflows, and even analytic workflows. So it's everything from being able to connect to data, to be able to blend and enrich data, to be able to run data science or machine learning algorithms, and then even being able to push that into a high performance, low latency analytic engine. And what we find is that it's all built on the open source KNIME project. So we capture a lot of the operators that they're developing, and then we take all of that, and via Yarn, very similar to what Fu described, that data torrent, we push that down so that it's parallelized against all of the nodes in a Hadoop cluster. And so a lot of it is about making the data in Hadoop much more accessible to business users and less skilled workers, somebody besides a data scientist.
Okay, and let me go bring in Nikita once again. I'm going to throw your slide up as well. Can you kind of talk about how you approach this solution vis-a-vis what these two gentlemen just talked about? Like how does someone actually put all this stuff together and make use from GridGain?
Well, I think the biggest difference between us and practically the rest of the field is that we don't require you to do any coding. You don't have to do anything. It's a plug and play. If you have application today, it's going to work faster. You don't have to change code. You don't have to do anything. You just have to install GridGain alongside your Hadoop cluster, and that's it. So that's the biggest difference, and we talk to our customers, whether it's, there's definitely myriad of solutions today that ask you to change something, program to a new API, use new interfaces, and whatnot. Our message is very simple. You already invest a lot of time into the Hadoop ecosystem. And whatever you use today, the MapReduce, the Hive, the Peak, or HBase, or any of the tools, continue to use. With GridGain, you don't have to change any single line of code. It's just going to work faster. So that's the biggest difference, and that's the biggest message for us.
Okay, good. And let's get Jim back in here, too. Jim, your quote is killing me. I had to write it down. I'm going to be tweeting that. I'll put it into some kind of deck. But the Hadoop ecosystem right now is like a pool party when the parents just came home. That is funny stuff, man. That's brilliant. Can you kind of talk about how you guys come onto the scene? How do you actually implement this? How long does that take? How does all that work?
Yeah, so there's a couple of varieties depending on the target customer, but typically these days you see evaluations where security is factored in and some of these hardening requirements that I talked about. What's happened in some other cases, and especially last year where people had big plans to deploy, is that there was kind of a science project, if you will, or somebody was playing with the technology, had a cluster up and working and was working with it, but then the security guy shows up, right? And if it's going to go in a live data center, it has to basically comply with the same requirements that we have for other equipment running in the data center if this is going to be an infrastructure that we build out. So it's really, you know, last year we had even some banks that told us they were going to deploy 400 to 1,000 nodes last year, and they're still sitting on a 20-node cluster, mainly because now a security person's been plugged in, and you got to be worried about financial compliance, about sensitive information that's sitting on the cluster, and so forth. So it really, you know, it varies by customer, but typically, you know, this is kind of what elongates the cycles, and this is typical of a new technology where if you really want to deploy this in production environments, it really has to have some of these other pieces, including the very valuable open source pieces, right?
Okay, good. And let's see, I'm going to bring Fu back into the equation here. We got a good question for you. One of the attendees is asking, how is data torrent different from Storm or Kafka or the Redis infrastructure? Fu, are you out there? Maybe you're on mute. Hey, Fu, can you hear me? You may be on mute. Let's bring Ray Wang back into this. Ray, you've seen a lot of these technologies and looked at how they work. I really love this concept of turning over control or giving control to end users of the operators. I like to think of them as like really powerful Legos that they can use to kind of build some of these applications. Can you comment on that? What do you think about all that?
Well, coming from a more technical background, I'd say I'm scared. I'm scared shitless. No, but on a serious basis, I think it's important, right? I mean, in order to get scale, there's no way you can only put so many requests. Think about the old way we did data warehousing, and the business side had to file the request for a report so that they could match, you know, all the schemas. I mean, it's like ridiculous. So we do have to get to a way where the business side of the house can definitely become data jocks. We actually think that in this world we're going to see more digital artisans, people that have the quant skills but also understand how to take that data and translate that into business value. And so these digital artisans, data artisans, depending on how you want to look at this, are going to need both, really, by first having the curiosity to ask the right set of questions, but also the knowledge to know when the data sets stink, right? If I'm getting a false positive or false negative, why is that happening? So I think a basic level of stats, a basic level of analytics, understanding that there's going to be some training required, but I don't think it's going to be too hard. I think if you get the right folks, that should be able to happen, and you can democratize that whole decision-making process. So I see that happening. We see that a lot of companies. Some of our financial services clients are doing that. Some of our retail folks are doing that, especially given the razor-thin margins that you're seeing in retail. We're definitely seeing that in high tech, just around here in the Valley. That's just kind of how people are. So it is emerging that way, but it's going to take some time because these basic data skills are still lacking, and I think we have to combine that with some of the stuff that some of these guys are doing here on this webinar.
Well, and you bring up a really good point, right? Like, how many controls do you want to give to the average end user? You don't want to give an airplane cockpit to someone who's driving a car for the first time. You know, you want to very closely control what they have control over. I guess my excitement kind of stems around being able to do things yourself, but the key is you got to put the right person in that cockpit. I mean, you got to have someone who really knows what they're doing. And no matter what you hear from the vendor community folks, like, some of these more powerful tools are extremely complex. I mean, if you're talking about putting together a string of 13, 14, 15 operators to do a particular type of transformation on your data, man, there are not many people who can do that well. I think we're going to have many, many more people who do that well because the tools are out there now and you can play with the stuff. And there is going to be a drive to be able to perfect that process, or at least get good at it. But we did actually lose Fu, but he's back on the line now. So Fu, the question for you is, how is data torrent different from like Storm or Kafka or Redis or some of these others?
I think that's a great question. So Redis, of course, is really an in-memory data store, and we connect to Redis. We see ourselves as really a processing engine of data, of streaming data. Kafka, again, is a great messaging bus. It's actually one of our favorite messaging bus. But you know, someone has to do the big data processing across hundreds of nodes that is fault tolerant, that is scalable, and we see that as the job that we play. So yes, we are similar to, as an animal to Storm, but I think that Storm was really developed a long time ago, even before Hadoop, and it doesn't have the enterprise level thinking about scalability to the hundreds of millions, not even billions of events, nor does it really have the HA capability that I think enterprise requires.
Right. And, speaking of HA, I'll use that as an excuse to bring Robin Bloor back into the conversation. We just talked about this yesterday. And what do you mean by high availability? What do you mean by fault tolerance? What do you mean by real time, for example? These are terms that can be bent, and we see this all the time in the world of enterprise technology, is that you get terms that other people kind of glom onto and use and co-opt and move around, and then suddenly things don't mean quite what they used to. I mean, Robin, one of my pet peeves is this whole universe of VoIP, and it's like, why would we go down in quality? Isn't it important to understand what people say to you and why that matters? So, but I'll just ask you to kind of comment on what you think. I'm still laughing about Ray's comment that he's scared shitless about giving control to these people. But what do you think about that?
I think it's a Spider-Man problem, isn't it? With great power comes great responsibility. You really, in terms of the capabilities that are out there, I mean, it trained to be an actuary a long time ago, and, I would have given my IT for some of the capabilities that they've got now. We used to do extraordinary amounts of what I would say was grunt work that the machines do right now, do it in parallel. And they do things that we could never have imagined. I mean, we would have understood mathematically, but we could never have imagined them doing. But, there is, some people understand data, and Ray's completely right about this. The reason to be scared is that people will actually start getting wrong conclusions, that they will wrangle with the data and they'll apply something extremely powerful, and it will appear to suggest something, and they will believe it without actually even being able to do anything as simple as have somebody do an audit on whether their result is actually a valid result. We used to do this all the time in the insurance company I used to work for. If anybody did any work, somebody always checked it. Everything was checked by at least one person against the person that did it, And these environments, the software is extremely strong, but you've got to have the discipline around it to use it properly. Otherwise, well, there'll be tears before bedtime, won't there?
I love that quote. Tears before bedtime.
That's awesome.
It's just funny stuff. Let me see. I'm going to go ahead and I'll just throw this slide up here from GridGain again. Can you talk about, Nikita, when you come into play, how do you actually get these applications supercharged? I mean, I understand what you're doing, but what does the process look like to actually get you embedded, to get you woven in, and to get all that stuff running?
Well, the process is relatively simple. You essentially just need to install GridGain and make a small configuration change just to let Hadoop know that there is now the HDFS, if you want to use HDFS, and you have to set up which way you want to use it. You can get it from BigTuff, by the way. It's probably the easiest way to install if you're using the Hadoop or Stack Apache. Hadoop, use BigTuff. We're part of BigTuff, can be downloaded from there. And that's about it. With the new versions that's coming up, literally in about a few weeks from now, by end of May, we're going to have even more simplified process for this. So the whole point of the in-memory Hadoop accelerator is to do not code. Do not make any changes to your code. The only thing you need to do is install it and have enough RAM in a cluster, and off you go. So the process is very simple.
All right. And let me bring John Santaferraro back in. We'll take a couple more questions here. John, you guys, we've been watching you from various perspectives, of course. You were over at Parexel. That got folded into Acan. Of course, Acan used to be called Ingress, and you guys made a couple other acquisitions. How are you stitching all of that stuff together? I realize you may not want to get too technical with this, but you guys have a lot of stuff now. You've got Data Rush. I'm not sure if it's still the same name, but you've got a whole bunch of different products that have been kind of woven together to create this platform. Can you talk about what is going on there and how that's coming along?
Yeah, the good news is, Eric, that separately the companies that were acquired, Pervasive, Parexel, and even what Acan had developed, everybody developed their product with very similar architectures. Number one, they were open with regards to data and interacting with other platforms. Number two, everything was parallelized to run in a distributed environment. Number three, everything was highly optimized. And so what that allowed us to do is to very quickly make integration points so that you can be creating these data flows. Already today, we've established the integration. So you create the data flows, you do your data blending and enriching right on Hadoop, everything parallelized, everything optimized. And when you want, you move that over into our high-performance engines. And then there's already a high-performance connection between Hadoop and our massively parallel analytic engine that does these super low latency things like helping a bank recalculate and recast their entire risk portfolio every 2 minutes. And feeding that into a real-time trading system, or feeding it into some kind of a desktop for the wealth manager so they can respond to the most valuable customers for the bank. And so we've already put those pieces together. There's additional integration to be done, but today we have the Acan Analytics platform as our offering because a lot of that integration was ready to go. It's already been accomplished. So we're stitching those pieces together to drive this entire analytic value chain, from connecting to data, all of the processing that you do of it, any kind of analytics you want to run, and then using it to feed into these automated business processes so that you're actually improving that activity over time. So it's all about this end-to-end platform that already exists today.
Yeah, that's pretty good stuff. And I guess, Jim, I'll bring you back in for another couple of comments, and then Robin, I want to bring you in for a couple, or just one big question, I suppose. And folks, we will keep all these questions. We do pass them on to the people who participated in the event today. If you ever feel the question you asked was not answered, feel free to email yours truly. You should have some information on me and how to get a hold from me. Also, just now, I put a link to the full deck with slides from non-sponsoring vendors. So we put the word out to all vendors out there in the whole Hadoop space. So tell us what your story is. Tell us what's going on. That's a huge file. It's about 40-plus megabytes. But, Jim, let me bring you back in and just kind of talk about, again, I love this concept where you're talking about the pool party that's come to an end. But could you talk about how it is that you manage to stay on top of what's happening in the open source community, because it's a very fast-moving environment, but I think you guys have a pretty clever strategy of serving as the sort of enterprise hardening vendor that sits on top or kind of around that. Can you talk about your development cycles and how you stay on top of what's happening?
Sure. It is pretty fast-moving in terms of if you look at just a snapshot updates, but you know, what we're shipping in functionality today is about a year to a year and a half ahead of what you can get in security capabilities out of the community today. And it's not that they're not going to get there. It just takes time. It's a different process. It has contributors and so forth, and it just takes time. But, you know, when we go to a customer, we need to be very well versed in the open source and very well versed in, mainly the security things that we're bringing. And the reason that we're actually issuing patents and submitting patents is that there is some real value in IP, intellectual property, around hardening these open source components. So when we support a customer, we have to support all the varying open source components and all the varying distributions as we do, and we also need to have the expertise around the specific features that we're adding to that open source to create the solution that we create. So as a company, although we don't want the customer to be a Hadoop expert, we don't think you need to be a mechanic to drive the car. We need to be the mechanic that understands the car and how it works, so we can understand what's happening between our code and the open source code.
Yeah, that's great. And Fu, I'll give you one last question, and then Robin, I'll have one question for you, and then we'll wrap up, folks. We will archive this webcast, as I suggested. We'll be up on InsideAnalysis.com. We'll also go ahead and have some stuff up on Techopedia. Big thank you to those folks for partnering with us to create this cool new series. But Fu, one of the attendees, writes, never ever goes down. I remember watching the demo of this stuff, and I was just, frankly stunned at what you guys have done. Can you explain how it is that you can achieve that level of no failover?
Sure. I think that's a great question. Really, fault tolerance for us has three components. Number one is you can't lose the events that are moving from operator to operator in the Hadoop cluster. So we have to have events buffering. But even more importantly, inside your operators, you may have state that you're calculating. Let's say you're actually counting money. There's a subtotal in there. So if that node goes down and it's in memory, that number is gone. And you can't start from some point, where would you start from? So there you have to actually do a regular checkpointing of your operator state down to disk. You pick that interval so it doesn't become a big overhead. But when a node goes down, you can come back up and be able to go back to exactly the right state where you last checkpointed and be able to bring in events starting from that state. And that allows you to therefore continue as if the event actually has never happened. And of course, the last point is to make sure your application manager is also fault tolerant, so that doesn't go down. So all three factors need to be in place for you to say that you're fully fault tolerant.
Yeah, that's great. And let me go ahead and throw one last question over to Robin Bloor. So one of the attendees is asking, does anyone think that Hortonworks, MapR, or another will get soaked up / invested in by a major player like Intel? I don't think there's any doubt about that. I'm kind of, I'm not surprised, but I'm fascinated, I guess, that Intel jumped in before like an IBM or an Oracle, but I guess maybe the guys at IBM and Oracle think they've already got it covered by just co-opting what comes out of the open source movement. But what do you think about that?
Yeah, it's a very curious move. We should see it in the light of the fact that Intel already had its own Hadoop distribution, and what is effectively done is it's passed that over to Cloudera. There aren't many powers in the industry as large as Intel, and it's difficult to know what your business model actually is if you have a Hadoop distribution, because it's difficult to know exactly what it's going to be used for in the future. In other words, we don't know where the revenue streams are necessarily coming from. With somebody like Intel, they just want a lot of processors to be sold. So, it's going to support their main business plank the more that Hadoop is used. So it's kind of easy to have a simplistic explanation of what Intel are up to. It's not so easy to guess what they might choose to do in terms of putting code on chips. I'm not 100% certain whether they're going to do that. I mean, it's a very difficult thing to call that. The next move at the hardware level, I think, is the system on a chip. And when we go to the system on a chip, you may actually want to put some basic software on the system on a chip, so to speak. So putting HDFS on there, that might make some sense. But I don't think that was what that money investment was about. I think what that money investment was about was just making sure that Intel had a hand in the game that is actually going forward. In terms of who else is going to buy, that's also difficult to say. I mean, you certainly, the SAPs and Oracles of this world have got enough money to buy into this. IBM's got enough money to buy into it. But, this is open source. IBM never bought a Linux distribution, even though it plowed a lot of money into Linux. And it didn't break their hearts that they didn't actually have a Linux distribution. They're very happy to cooperate with Red Hat. I would say maybe Red Hat will buy one of these distributions because they know how to make that business model work. But it's difficult to say.
Yeah, great point. So, folks, I'm going to go ahead and just share my desktop one last time here and just show you a couple of things. So check out, after the event, check out Techipedia. You can see it out on the left-hand side. Here's the story that that yours truly wrote, I guess a couple months ago, well, a month and a half ago, I suppose. And it really just kind of spun out of a lot of the experience that we had talking with various vendors and trying to dig into understanding what exactly is going on with this space. Because sometimes it can be kind of difficult to navigate the buzzwords and the hype and the terminology and so forth. And also a very big thank you to all of those who have been tweeting. We had one heck of a tweet stream here going today, so thank you all of you. You see it just goes on and on and on. A lot of great tweets on TechWise today. This is the first of our new series, folks. Thank you so much for tuning in. We will let you know what's going on for the next series sometime soon. I think we're going to focus on analytics probably in June sometime. And folks, with that, I think we're going to go ahead and close up our event. But we will email you tomorrow with a link to the slides from today. And we're also going to email you the link to that full deck, which is a huge deck. We got about 20 different vendors sent us their Hadoop story. We're really trying to give you a sort of compendium of content around a particular topic. So for bedtime reading or whenever you're interested, you can kind of dive in and try to get that strategic view of what's going on here in the industry. And with that, we're going to bid you farewell, folks. Thank you again so much. Go to insideanalysis.com and Techopedia to find more information about all this in the future, and we'll catch up to you next time. Bye-bye.